Okay, this is a quick video on some properties of ethers that is important to keep in mind. So water and alcohols and ethers all share a lot of similar structural properties. In each case, the oxygen atom is sp3 hybridized. You have two lone pairs on the oxygens and you have two R groups coming off. Right, the only difference is in water we have two hydrogens. When we have alcohols, we replace one of the hydrogens with an alkyl group, and in ethers, we replace both carbons with an alkyl group. The bond angle tends to get a little bit larger when we go from water to alcohols to ethers as we get bulkier groups on here, but the structure is relatively similar, right? And then another thing that they have in common is the polarity, right? So the oxygen is more electronegative than the hydrogens or the carbons, and so this end of the molecules, the oxygen end, is always going to be partially negative, and then the opposite end of the molecules is always going to be partially positive. Now, the structure of water and alcohols and ethers all end up with the oxygen being partially negative and then the hydrogens and alkyl groups being partially positive, but there's a big difference in intermolecular forces in water and alcohols versus ethers. Right, so remember the alcohols have relatively high boiling points because they can hydrogen bond with each other. Right, in order to have hydrogen bonding, I have to have a hydrogen directly connected to an oxygen, and then the other molecule, I have to have an electronegative or a partially negative oxygen, nitrogen, or fluorine. And so in alcohols, we have hydrogen bonding. Now, ethers can act as hydrogen bond acceptors, because remember, when we talk about hydrogen bonding, one of the molecules has to have the hydrogen directly connected to an oxygen. So if I have an alcohol, it meets that first, more strict criteria. The second criteria in hydrogen bonding is met as long as I have a polar molecule with an oxygen, nitrogen, or fluorine, right? And the ethers meet that criteria. So an ether can hydrogen bond with an alcohol. But if I have two ethers, they can't hydrogen bond with each other, because in order to have hydrogen bonding, I've got to have a hydrogen directly connected to an oxygen, nitrogen, or fluorine. And in the case of ether, both groups coming off the oxygen are alkyl groups, and so I don't have a hydrogen directly connected to the oxygen. And so in the case of ethers, the strongest intermolecular force is dipole-dipole interactions, right? And so that's weaker than the hydrogen bonding that we would have in alcohols and water. Right, so because ethers can't hydrogen bond among themselves, their boiling points are much lower because they have lower intermolecular forces than alcohols of comparable sizes. Right, so when we think about ethanol, right, it is a constitutional isomer of dimethyl ether, right, but dimethyl ether has a much lower boiling point than ethanol because ethanol has hydrogen bonding, where the best dimethyl ether can do is dipole-dipole interactions. Right, and if we compare that to propane, that's about the same molecular weight as these other two molecules, right, it has a lower boiling point still because all propane has is dispersion forces, right? It can't even do dipole-dipole interactions. Now, it is true that for ethers, as they get larger, the boiling points increase, right? And this is true in general for all molecules, right? As a molecule gets bigger, we have stronger dispersion forces because we have larger electron clouds. So it's generally true that if we have a single type of functional group, right, in this case ethers, as the ethers get larger, the boiling points increase. Right, so a really common use of ethers is to use them as solvents. Ethers are fairly unreactive. Also, because they're sort of an in-between between being polar and nonpolar, they're able to dissolve a wide variety of organic compounds. And then because they have relatively low boiling points, it's relatively easy to remove them and isolate a solute by just evaporating the solvent ether. All right, so in the next videos, we'll get into more detail and look at some of the reactions that ethers are involved in.